Tom Campbell here. If you find something of significant value in our videos, please consider supporting their production through our Patreon account or through a one-time donation. The links are in the description below. Thank you and enjoy the video.
Good afternoon, Tom, and thank you for being here for Tom Campbell Answers Your Questions. We have a mixture of questions that were emailed and some of the fireside chat questions from the MBT forum that we did not get a chance to get to. So we're going to start with the first question from Maxie. And the question is about astrology. He feels that the horoscopes are quite accurate. Could you speak to that?
Well, sure, I could. I would agree with him. I've also seen horoscopes that were very accurate and in their predictions, and those predictions took place over, a year or so. So it wasn't just real short term; it was long term. What's going on here is that the astrologer is gathering information from the probable future database with their intent. Now, they don't know that that's what they're doing, but they will often need a kind of a quiet place or some quiet time. They generally don't do their astrology readings, while fixing dinner or, giving their children a bath. They need to get their mind in the right space. They need to get into that intuitive region of awareness that supports getting data out of databases. And then they think about what they're doing. They're coming up with they're trying to get information on future probability. Well, when you do that, that is the same as sending a query to this database. And with practice, you get the answer back and are able to explain, justify, or whatever this answer in terms of planets and moons and other heavenly bodies and how they're moving. So that's one way, to look at it. That the most precise astrologers, if it were just the motions of the heavenly bodies relative to where you were born and when you were born, the most precise and best astrologers would be computers, because they can compute those positions to 20 decimal places. They can be much more accurate than any astrologer could be. Matter of fact, most astrologers probably do work with computers and with software these days, not with a stubby pencil and a protractor and a slide rule. So if it were just a matter of reading the stars or reading the planets and moons, then computers would be the most accurate because they do the most accurate computations. But that's not the case. Computers make very mediocre astrologers. They're not all that good. The best astrologers are those that are gathering the data with their intent. And that's why the data is mostly correct for these people. Now, all astrologers are not necessarily gifted, and they're all not necessarily as good at getting data out of databases as others. So just like in any other area of expertise, you'll find some people who are excellent and some people who are not. And it's just a matter of, I guess, asking people who have had their horoscopes read, how accurate they were. Because those people who are accurate tend to be accurate pretty consistently. Now, there's another thing that also will could take place here, and that is that when the larger consciousness system needs to create more individuated units of consciousness to play avatars in this virtual reality, it needs some way to differentiate them. It needs some random way to pick the various attributes of these new IUOCs. So now we can think of several ways it might do that. You know, it might take some unique data about that person, like perhaps the time they were born and where they were born, and use those two things as seeds for maybe a random number generator, so that every location and birth time would kind of come up with its own unique seeds for generating random numbers, and then use those random numbers to select personality traits. So if they get these random numbers, then they're bossy. They use these random numbers, then they are intellectual, and so on. You know, just have personality traits versus various selections and combinations of random numbers. And maybe the personality traits might be laid out in a grid of maybe 8, 16 different personality traits, because we have Myers-Briggs, and we have some other people who kind of take human personality and they seem to be able to break them up into categories. I think there's, not sure now, there's either 8 or 16 categories when that gets broken up into all of its subsets. So that may be a way that it could break them up, you see. So then it may take people of certain places and birth times, and they would tend to maybe clump together in the attributes that they would get based on these algorithms. So there's a possibility that the system actually uses birth time and birthplace to help it pick attributes for its new IUOCs. It may also use the Myers-Briggs kind of a thing. Now, I'm not saying it uses these things exactly, but I'm just making the point that the system has this problem of picking attributes for new IUOCs. It doesn't want them all to be the same. They have to be different. Their characteristics have to be spread, you know, over a certain distribution. And there's several ways to do that. So how does it do it? I don't know, but it's possible that that might be the link to astrology, that the astrology, that birth date and birthplace may have some connection to the process by which the system comes up with personality characteristics for its new IUOCs. Just a possibility. Don't know that that's the way it's done, but it is a possible connection. So then you'd have two things. You'd have one, you'd have the astrologer getting data from the future probable database, and you'd have that data that they get would now naturally lay out to be able to be interpreted in terms of motions of heavenly bodies, you know, based on birth time and birthplace. So that's a possible connection. But I agree with you. I too have found some astrologers to be amazingly accurate in what they do. But it's not just about computing the numbers and seeing where all the heavenly bodies are. There's obviously something more to it than that. And like most things, the active ingredient tends to be the focused intent of an individuated unit of consciousness. The focused intent of consciousness is what gathers the information. And I think this is not different. That's true of all the ways that we know of prognostication. When people read tea leaves, it's because the tea leaves have so much uncertainty into how they might fall out that if there's a pattern and a set of things that belong to those patterns, then that's just a way the system can use that uncertainty to give a message as far as the output of the probable future database can now be put out in that form, you know, tea leaf shapes, or what the ancient people used to get a handful of chicken bones and throw the chicken bones on the ground, and how those chicken bones landed, and the different bones being different to, you know, being associated with others laying next to them or crosswise to them or parallel with them, and how they spread out would tell the future. Well, that's just another case where there's a lot of uncertainty, and the system can use that uncertainty as a communication tool for helping people take the data that's in a future probable database and interpret it in those terms, in terms of chicken bone positions, or in terms of planets and moons and things, or in terms of tea leaves. These are all similar, in the way they work. And they're all basically functions of an intent collecting information from a probable future database.
Okay, Tom, the next question comes from Ellie. If we take the latest findings of quantum physics by many physicists seriously, that time-space is doomed, I can only conclude that any change in evolution belongs to our avatar world, which operates in time, space, and time. You believe the universal consciousness is not infinite and it is evolving. If the reality of the existence is outside of time and space, how can you establish change and evolution of larger consciousness?
It's outside of space, definitely, but it's not outside of time. Now, the larger consciousness system has created time as a technology. Okay, it just, can oscillate back between a 0 and a 1, this way and that way, like a metronome. 1 0 1 0 1 0. That's a metronome. So that creates a clock. So this technology, any digital system can create a clock just by oscillating between a 1 and a 0 regularly. So it creates a clock, and it then has the ability to have time. So time is a creation of the system itself. Now, that's not exactly the same time as we have in our simulation. Every simulation runs on its own clock. So our simulation, called, Earth and its universe, let's say, that has its own clock. And I call that, each tick of that clock delta T in the book. I name that capital delta T, whereas the delta T that, say, is at the computer, that's a much smaller delta T. So I have it lowercase delta T. So you have various clocks, but they all are kind of run off of or created from the original clock. So let's say our delta T, which has bigger delta T's, maybe only takes one unit of delta T, takes one tick every, say, billion ticks of the larger consciousness clock. So our clock runs a lot slower, but it's keyed off of the fundamental clock, which the larger consciousness system has. So that's where time comes from. Now, time, ordered time, regular time, then enables things like evolution, change, learning, growth. All of these things require time. Choice requires time, before choice and after choice. Consequences require time. Everything just about requires time. So time was a very important discovery. Now, by time, I mean regular time. Time that has a regular beat, like a metronome. Okay, so that's how the system can evolve. It does have time. Now, our virtual reality here that we call our universe, it has this time derived from the system's clock, but it also has space, which is created by the computer. How does a computer create space? It picks a point, calls that the origin, then defines 3 orthogonal unit vectors, or an x, a y, and a z axis, all orthogonal to each other. That defines space. Space is defined mathematically, logically. So that's how that works. The fact that there is no space-time, and you've been reading those headlines lately, I've seen those too. It's kind of one of the new things to say in physics is, space-time's on its last legs. We're going to let go of space-time. Well, space-time, as created by Einstein's relativity theory, is a very specific thing. Okay, that is space that is also a function of time, and time that's also a function of space. So they call it space-time. It's a combination of those things. It's a mathematical construct. It's part of Einstein's relativity model. It's just a model. It's a mathematical model. Mathematics is the logic of quantity. So Einstein was trying to add gravity to his relativity theory. And in doing that, he needed to have some way of expressing why masses would tend to move toward each other with a force. He needed that. That's what gravity is all about. So he came up with this model of saying, oh, mass deforms space-time. So if you have a big mass, then it's like a big, heavy bowling ball on a trampoline. It deforms the trampoline so that the trampoline, now the ball's at the bottom of a vortex. So anything that gets on that trampoline, not that distant from that ball will roll in toward the ball. Ah, there's your force. That's why masses, move toward each other. So that's just a model. It's a mathematical, what do we call it? It's a mathematical way of coming up with gravity. So, where did that come from? Does that mean there's really space-time out there that stretches? No, it doesn't mean there's really any space-time out there that stretches when masses get to it. It just means that model is consistent with our measurements. It's as if reality were made of a stretchy space-time that got deformed by mass, as if. But don't forget the as if. You see, just a model, a mathematical model. It's a good model in that it computes a lot of things that actually we measure and say, well, that's true. It does work like that. But then we had another model before that, which was Newton's model. And that was just simply that masses attract each other, in inverse to the square of the distance between them. The force of gravity was G, a constant, a proportionality constant, times M1 times M2 divided by R square, where the M1 and M2 were the two masses and R square is the difference between their centers. So that was another model of gravity. Now that mathematical model is a very good model, but it didn't work so well for relativistic situations where you have very high speeds. And of course, Einstein's model was able to add relativistic effects to his gravity model. So his model is a more general model than Newton's, but they're just models. Don't take it too seriously. It's just like electrons. Electrons don't really exist either, but we measured mass, we measured charge. So we said, aha, it's a particle with mass and charge. And we'll call that particle an electron. But you see, nobody's ever seen an electron. We don't ever deal with electrons directly. We deal with the effects of electrons. So it's all based on the effect, as if there were an electron. But the idea of an electron itself is just something made up. It's a model, just like space-time. It's a model, okay? That's why when we get to quantum mechanics and we say, wait, particles don't act like little chunks of mass anymore. Electrons don't act like that. Electrons distribute themselves in a diffraction pattern like light. Why do they do that? Well, they can't do that if they're little chunks of mass, because little chunks of mass don't work that way. So how do they do that? Well, they're not really little chunks of mass after all. That model then is broken. And we know that it's a probabilistic theory, right? The quantum theory is basically about probability. So now people are seeing some of the limitations of Einstein's viewpoint of space-time, that model, just like quantum mechanics showed the limitations of calling everything particles. So you're having papers now being published about how we're going to go beyond space-time. We're going to have to let that model go and go to a more general model yet. Well, okay, that sounds like progress. We may indeed do that. The problem is that you and most physicists have as well, is that believing that these models are actually real things, that they're somehow physical things. Space-time's this physical thing. Electrons, this physical thing. They're not. They're virtual things. They're computed things. And that's all the difference in the world. They're not little chunks of matter running around that we call electrons. And there isn't this stretchy space-time out there that acts like trampolines whenever big masses get there. Just a model to fit the data. And when the model no longer fits the data, just like Newton's gravitational model, we move on to something more general. In the end, the most general thing is going to be understanding reality as virtual. And at that point, space-time and electrons will all be thrown away because they will all just be computations, not real material things.
All right, Tom, thank you very much. The next question comes from Ian in Switzerland. There is cause and effect. So doesn't this mean that human beings with their decisions and state of consciousness are ultimately the result or the sum of their previous experiences? How can we say then that we have free will? I mean, it's like mathematics, 1 + 1 = 2. The only difference is that there is a wider range of possible outcomes and results in regards to human experiences. But in the end, if we would know the beginning point, we could calculate the probable or most likely, or even the exact actions, decisions, etc. a human being is going to take and make, right?
Wrong. Now,
Okay.
if you start with a premise that this is a physical reality, which is kind of an underlying assumption that you have, stated or unstated, you're coming from this premise that there is a physical reality. This physical reality can only be in so many states, and it has so many possibilities. Okay. If you start with that assumption, then your argument holds water. It's true. If this is a physical reality, then if we knew the state vector for every particle in the physical reality, then we could calculate the future. Exactly. Because we'd know, we'd have all the information about all the physics, how these particles interact with each other. So if we knew the state of it at any one time, we could calculate the state of it a next delta t and a next delta t. And we could do that precisely so that there would be no free will. There would be no consciousness. There would be only determinism. Nothing would change ever. It's just a machine that runs its course. Okay, so not only would there be no free will, no consciousness, and really no time, because time is irrelevant. Time's just it's like a frame in a movie. It's just a slice of the inevitable. So there's none of that stuff in there. All there is materialism and determinism. And if you believe in materialism and determinism, that is your world. The trouble with that is that it's not a very useful answer. It's where it goes. Its explanations are what I'd call just the null set. It's nothing there. There's nothing. There is no change, no point, no purpose, no reason for it to exist. It doesn't have anything that compels it, that makes it compelling as an argument. It's just, Okay, everything is static. It's always been that way, always will be that way, end of story. Well, that's a very boring story. There isn't any plot to that story. There isn't any purpose to that story. You see? So it's not, it doesn't ring true to our own experience. Yes, I know you can say that our own experience is basically, an illusion. But that doesn't really make a lot of sense to me. I make choices, you make choices. Some of the choices I make could be pretty easily predicted. Sometimes I'll make a choice that just takes a sharp right turn or a sharp left turn, or just seems to teleport someplace else that even surprises me that I made that choice. Yes, indeed, we are a summation of all the choices we've made. But those are choices, free will choices. We are a sum of all the free will choices that we made, because well, not just that, we start with something as well. We start as consciousness, and then we make choices. Those choices help us evolve or de-evolve. And what we are, what we become, depends on those choices. But what we are doesn't depend on those choices. What we are is something different. We're not just choices. So it's just two different models. Okay, you have in one corner materialism and determinism, no time, no consciousness, no point, no purpose, nothing. On the other corner, you do have consciousness. It does make choices. To make a real choice, you have to have free will. And then you can also have change. You can have growth. You can have learning. You can have evolution. Well, we look around us and we see growth and learning and evolution all over. We see the evolution of our universe, the evolution of, from the Big Bang to all the stars and planets and asteroids we have out there now. We see evolution on a planet. We see evolution in, subsets of the planet, evolution in the mountains, that they were bigger, now they've worn down, evolution in the seas, everything changes. So we see that nothing stays the same. And for all of that to mean nothing is a very difficult logical leap, because things don't happen for no reason. It's not like, well, there was nothing and then there was everything and it was done, end of story. It's just nonsense. There was something, it was able to become self-aware, it makes choices, it evolves, and it's created everything else. That's a story that has purpose and point and direction and goes someplace. So either one are logical. Either one, you have to start with what? Conjecture. Both places, you start with assumptions of, of being material and deterministic, or assumptions that start with consciousness. One of them leads to a null zone of no significance. The other one leads to everything we know that exists and explains who we are, why we are, how we do the things we do, why some of us are happy, why some of us aren't, the things we build, the things we are, the evolution of humanity over time and the direction it's taken, the evolution of the critters here on the earth, the evolution of the stars and planets and so much stuff has changed. And we have now good logical explanations for it. Physics, we have good logical explanations for it. We have causality, not dead causality in just a material sense, but a larger causality in the consciousness sense. And the material sense is a subset of that consciousness sense. So yes, determinism and materialism is a logical possibility, but it's just irrational, doesn't make sense, doesn't go anywhere, pointless, whereas the other is not. So, you get to choose which what assumptions you start with. And the reason that you have to start with assumptions is because we can't get out of who and what we are to see ourselves from the outside, to see ourselves objectively from outside of ourselves. That's the only thing, that's the only way you're going to see your own beginnings, is to get outside of who and what you are. You can't see your beginnings from the inside.
Now you've developed your My Big Toe beginning with consciousness as fundamental. And with that viewpoint, consciousness you describe as a social system, and a social system has purpose.
Right.
So that is your whole viewpoint on that, and
Right.
more of
Yeah.
an efficient thing.
Right. Not only that, not only does consciousness imply purpose and value and meaning and significance. You see, determinism doesn't. There's none of that stuff. There is no meaning, significance, value, or purpose. It just is. Has no value, has no significance, has no purpose. So that's what I say. It's a null set. It doesn't really have anything of that's useful as far as building a theory goes. But not only that, with this consciousness model of mine, I also can derive physics, a better physics than physics. So, things that answer all of the outstanding paradoxes in physics. Why see a constant? Why are particles probability distributions? How does the Zeno effect work? On and on and on. What were we before the Big Bang? If the Big Bang defines our reality, where did the Big Bang come from? Where did that ball of plasma come from? So there's lots and lots of paradoxes in physics. Where does time come from? Where does space come from? Where does charge come from? We don't have any source of any of that stuff. That's all the basic stuff of physics, and physics can't even say what its causality was. What caused charge? What causes time? You see? So all of physics is based on a whole bunch of things that we have no idea where they came from. They just poofed out of space, empty space from nowhere. There they are. They just are because they are. Well, that's not science. That's conjecture. That's not good science at all. Whereas in my theory, I can explain what all those things are and why they are that way. Not only what they are, but why they exist, where they came from. So it's a more general model that explains a lot more physics than physics can explain with its materialism determinism model. So it does better physics, not only more general, but even the details. Understand quantum mechanics. Quantum physics isn't weird physics. It only looks weird because you're trying to force it into a straitjacket of materialist determinist thinking. And if you try to cram it into a materialist viewpoint, then it's weird science because it doesn't abide by materialist, logic. But when you understand how physics actually works, then quantum mechanics is just logical science like any other science. It's not weird at all. So that's the thing. All right. Now, what does physics bring you? Well, it brings you a viewpoint of materialism and determinism, and that basically has no value, no purpose, no point, and goes nowhere. Okay. And cannot explain its own measurements, its own experiments. It just calls them weird and moves on. It can't really explain how they work that way. Can't explain why C is a constant. Can't explain so many things. Can't explain where its fundamentals come from, like time and charge. Now you have another viewpoint that starts with consciousness. It adds purpose and point and value and significance, gives us reasons for who we are and why we're here and what the point is. It's a social system that tells us, that becoming love is where we're evolving toward. It's got all that to it, and it explains quantum physics, and it answers all those other things in physics. So it's just a better, more general model that actually goes someplace and amounts to something, rather than saying, well, it's all material, it's deterministic, end of story, no value, nothing.
And
That's
really, nothing outside of, if they're hanging on to the materialist view, there's nothing outside of this reality. And your explanation includes a larger consciousness system of which we are a part, who has created, if you will, this virtual reality for us to
mhm,
experience in. And I think the love factor is also another thing that we have a lot of evidence of.
sure. Well, there's lots of evidence. That's the point. If you just look at the evidence, you'll see that the virtual reality theory provides much stronger, much better evidence as far as our understanding of the world, both the objective world and the subjective world, than does materialism and determinism. So if you just look at it as a scientist and say, okay, here are the two theories, how do they describe the facts we know? And you'll find one describes a subset of those facts and doesn't describe the rest of it at all, like the subjective part. And the conscious side describes all of it in detail. So yeah, two different ways of looking at reality. And both are logically possible. It's just one is rational and has value and substance, and the other one doesn't.